Namaskar, my dear friends. So, as we have been seeing the Spartan 7 FPGA design, and in that we were discussing last evaluation kit available with AMD. So, that was based on XC7S100 FPGA. And this is the device that is there, the outline of this particular device, and all the peripherals we had already seen. Now, we want to discuss about the user guide of this particular design and development. Okay. So let's get into the evaluation board. So in evaluation board user guide, once you download, I will give you the link for this particular evaluation board in the description so that you can understand particularly. Okay. Now let's get into the directly available things. So once you come back to the block diagram, so the best part is this is the FPGA that is available. This is my FPGA. Okay, and each of the different peripherals is connected properly. Okay, so as you can see, let me just increase the size and show it to you. Like we have FMC LPC connector. Okay, then we have MSP 430 here. We have FTTDI, like a USB to UART chip. Then we have 6 PMOD connectors is there. We have HDMI output is there. We have system like monitor and XADC is there, like ADC. We have EPROMs. Okay, so their page numbers is written so that you can go to that page number so that you can have a proper understanding about the circuit. Okay. Similar to that, we have quad SPI, we have user interfaces like LEDs, then dip switches and switches, push buttons, all these things are there. We have MIPIs, two are there, one is page number 8, one is page number 11. Okay. Similar to that, we have two Ethernet, so one Ethernet is here, one more is here. We have DDR as well. So this is a complete, like block diagram of this particular schematic of evaluation board that is given. And this is the power supply system. So you can see we have 1 volt, then we have 1.8 volt, 2.5 volt and 3.3 volt. So we have also given you lot of, like understanding of like how to design power supply for FPGAs. So we will be taking these kind of, like information so that we can design our power supply very easily. However, our power supply design will be much easier than maybe probably than this. Okay. Anyway, so this is the block diagram of this particular device that we are going to discuss right now. Now let's go down. So as you can see, board features. So in board feature basically is nothing but the PCB that we are discussing. The evaluation kit is having this particular FPGA. You can note down the part number so that it will be easier for you to understand and design and develop. Then we have form factor and all these things. We have configuration. We have already discussed about all these things, so I don't want to repeat again and again. Okay, so this was the features of this particular board. Board specification basically like dimension and environment. So this way you can, like it will help you to understand and design your, like documentation as well. So this is how you actually understand. Similar to that, coming down, let's go down board setup and configuration. So all these things are there. Nothing much. Yes, this is what is, like needed for you guys. So you might not see clearly. However, if you try and download this particular document and see like 00 and then like 16, 14, 5, 17. So all these are numbered very properly. So it is kind of acting as a legend. Okay, and this legend will make you map what is this particular thing or what is this particular circuit or part once you have this particular board in your hand. Okay, so let us say pin number this 9 number, or let us say number 1. So number 1 is your Spartan, right? So Spartan 7, you have this call out and you have the features and like notes and all schematic page numbers. So all these things are there very properly. So let us say 6. So 6 is nothing but your I2C programmable clock LVDS, and this is on page number 8. So once we open the circuit, this is the circuit that is there, which is 27-piece circuit. So this circuit will be having that particular information. Okay, so this is how you can search any legend or any, like call out, and this way it will help you to make yourself comfortable and understand the complete evaluation board very easily. All right. Now let's get more into that. So you understood the board outline and board, like features and what is the thing that is available with the board. Okay. Default switches and jumper setting and all these things I don't want to discuss right now. So basically this is complete, like a user guide for this particular evaluation board that you want, you can have this. Okay. And this is the way it is connected, like how battery is connected, so that it will help you to encrypt key backup circuits. So basically one coin cell is there which will be helping you to retain the information. Similar to that, like a lot of voltages are there. So we have bank wise, so like bank 0, 13, 14, 15, 16, 33, 34, 35, 36. Okay. And we have different power nets. So we have 3.3 volt, 1.8 volt, rest all are 3.3, then 2.5 volt as well as 1.35 volt. So I think 1.35 volt is nothing but for DDR. Okay. Then we have adjustable voltage and all. If you want, you can utilize these two adjustable voltage, these two banks with different adjustable voltage as IOs. Okay, so if you want, you can do that as well. So nominal it is 1.8 volt set, but if you want, you can set it to 3.3 volt as well as 2.5 volt. So it is having almost all the features that we need while developing a FPGA circuit. Okay. So anyway, our circuit, our design and development will be much, much simpler. However, I want you to go through this particular user guide, and I too, like want to give you an understanding about how complex an FPGA is. And once you understand, it becomes quite easy. Okay. So you can see now each and every component will be explained properly, like how DDR is interfaced and everything. So I'm not going through each one of them one by one. Okay. Let me just go through this QSPI. So you can see QSPI, we need flash like memory lines like 0, 1, 2, 3. Then we need one clock and we need one chip select. So this much is enough. So only 6 line will be required to have my Spartan 7 FPGA configured through the QSPI. Okay, so this is how it works. Very simple. And you know already that SPI signal we have what? Like MISO and then MOSI and then clock line and then chip select. So 4 lines are there, but in quad SPI 2 more line will be there. Okay, so basically D0 and D1 we are using in 2 lines, then 4 lines we will be using D2 and D3 as well. So total 4 lines are there. So this is how we have 4 lines. All right, so this was about this. Then we have JTAG connector and how JTAG is configured. So it is very, very complex. I will not discuss right now. And then we have clock generation. So clock will be required, clock will be very, very, like complex, as well as, like it is very informative. So you must understand how clocks are distributed in this particular FPGA. Like we have 33 megahertz, 33.3 megahertz, we have 400 to 800 megahertz for like DSQ lines, or nothing but it is like DDR lines. We have 125 megahertz. So several clocks are there and how they have been generated. So this gives you a very good understanding how do we work actually. Okay. Anyway, so yeah, they have again given like given you the clocking diagram. So in each of the banks, what is the clock that is used and how it is generated. Okay, so this is a complete block diagram that is given. I'm not discussing right now because in the circuit explanation I'll discuss each one of the pages one by one. So let us say once we take MIPI cameras, what is the clock, what is the circuit, and how it is interfaced with my FPGA. So this itself will be one complete session. So this is the way we have total, let's say 27 page. So around 10 to 12 sessions I will take to completely, like discuss this particular circuit, so that you can have a proper understanding and proper learning about it. And then we will be able to design and give you the circuit. So let me show you. All right, so if I show it to you like how our circuit will look like, our circuit will be very, very simple. So let me just give you an example, or a, like an overview. So let us say I'm opening a circuit which we have designed for FPGA XC7S100 FTGB 196C. So this is 196 pin device that we have developed, 196 pin FPGA. This is also a Spartan 7 from AMD. Okay. So as you can see very nicely, like it has been, arranged in block by block, like U1A, U1B, U1C, like that. So part by part. So this is my configuration block. You can see you have configuration, you have JTAG connector here, and several indicator and all these things are there. We have QSPI flash memory to configure that. We have deep switches and everything for mode settings. Okay. So total 10 pages are there. You can see you have user IOs and like push buttons. We have LEDs. Then we have deep switches. We have several methods of connecting the LEDs, like as a sink, as a source, and then trying to power up your LEDs through user IOs. So there are different methods that we have utilized to give you almost all the pictures. Okay, similar to that we have some banks which is free available. Okay, then we have power supply, like how power supply decoupling capacitors will be chosen. So this is also a very good technique. Okay, so those understanding you should have, how grounding has to be connected. Okay, so this is the way we actually design the symbol as well. So basically in FPGA, you have to first develop the symbol also. So how to organize your symbols properly. Okay, so this is a great understanding about this particular symbol formation. Okay, similar to that we have power supply. So power supply, only one IC I have used from analog devices, that is going to give you four outputs. So one is like 1 volt is there, then 1.8 volt, then 3.3 volt, and 1.35 volt. So only one IC is enough for me to complete like a power supply design for my FPGA. Then we have power supply system input, like let us say we have input connector here, and then we have a MOSFET to switch that on, and then it is going to go to your main input. Okay, if I want I can put here one like a inductor and proper like filtering all these things, or protection circuit. Similar to that same concept I have used in the evaluation board. Thanks to AMD for that, just to make sure that you also understand this. Otherwise it is not needed, you can directly power it up, not a problem. Then this is the main power supply that is going to give you input voltage, which you can vary like let us say 9 volt to 20 volt or something like that, and still it can give you the output of 5 volt. So 5 volt I am generating from this particular regulator, and this I am going to monitor as well. So this I will explain you during the circuit design. Okay, similar to that we have external ADC that is used. So external ADC have used for different purposes. So we have multiplexer, then how it is like each of the voltage levels has been transferred to this data line, and this data is coming as input here, and after buffering and filtering and buffering, it is going to my ADC converter. So this is a 16-bit ADC which is connected to my FPGA. Okay, similar to that we have DAC as well. So DAC we will explain you later on. Then we have like SPI, like flash is there, flash memory. Okay, so this was all about this. Okay, so we will discuss this particular circuit in detail once we come back to this. However, our main aim is to just complete the user guide that we are discussing right now. So you can go ahead and like I'll give you the link for this particular user guide in the description box, so that you can have a proper understanding. So as you can see in the user guide, each of the circuit block is explained properly, like how FTDI USB to UART circuit is connected, and it's pretty difficult here, but in the circuit it will become easy, like how my Spartan 7 FPGA is there, how it is connected with my like a system controller, that is my microcontroller, and then it is actually FT4232H is there. This is having the UART to USB connection. Okay, so this is also connected directly to FPGA and through the microcontroller to FPGA. So this is complete like a loop that is working on. Similar to that, we have dual Ethernet. So Ethernet is there, which is having two Ethernets are there. And similar to that, we have JTAG, Ethernet, JTAG, and all these things. Okay. Then we have I2 bus topology. Okay. So I2 bus topology is basically how it is connected with I2C. So there are various features. So I'm just like scrolling through because each of the pages they have explained you the FPGA, the system controller, and the interface. Okay, so this is how it is working. Okay, so how HDMI is IC is selected, and how it is like going to give you the HDMI connector output. So this is my output connector, and this is my HDMI transmitter, and this is the FPGA, right? So this is how it is actually interfaced properly. So if you want, you can understand what are the signals that are used. So this helps you to actually like appear in your interviews as well. Like they may ask you what are the things that is available in HDMI interfaces. Okay, so we have HDMI H sync, then V sync, then HDMI clock is there, HDMI INT is there. We have device enable, we have SPDIF. Okay, then all these things are like I2CSCL, I2CSD, HDMI. All these things are there. So we have to understand this is the way we can find it out. Coming back to MIPIs and like DSI. So one camera interface is there and one display interface is there. Okay, so basically this mobile industry processor interface basically helps you to have a very high speed, proper, like interface of FPGA with your this MIPI's interface. And MIPI interface, we have lot of things like we have like D5, C5, M5. So basically they are going to support with D5. Okay, so M5 and C5 they have not put it here. Good. So we have this is the MIPI SI interface is there. Then we have DSI interface. Okay. So it's complete a very good learning. Like I have myself enjoyed around 4 5 years ago. This particular FPGAs I had used, and this is the evaluation kit that was like used very prominently for my development. Okay. However, most of the parts I have not used because they may go a little bit obsolete, or maybe they have chosen some other parts. In addition to that, we can like explore ourselves and try to find out our own parts. Okay. Then you can see you have like a power, user, status LEDs and all these things. So how power is indicated, how status LEDs are indicated, how user LEDs can be indicated. So all these things are there. Okay. You have user IOs like LEDs and dip switches and like a reset button and push buttons. All these things are connected very nicely. So you can see we have 8 LEDs, 8 deep switches, 8 deep switches more are there. Okay, then we have 5 push buttons and one more push button for CPU reset. So total this many user IOs are there. We have PMOD connector. So PMOD connector actually helps you to interface a separate, like sensor boards or maybe some other peripheral boards which has like 12 pins that can be connected directly to the Spartan 7 FPGA. Okay. So there are various peripherals available in like a micro bus kind of thing. Basically, it will be having UART interface or I2C interface or SPI interface. So it's very easy to just connect, plug in, and start interfacing with your FPGA. So you can send data to from FPGA to your interface board, or maybe from board you can read some data to the FPGA, so that it becomes a very like a versatile system. So almost we have reached. You have system controller, so you can see how this is the main part. Like I will not be introducing in the beginning system. Okay. So basically they can make you understand very properly like how FPGA can be controlled through the microcontroller. So microcontroller can act as a like master, or sometimes it can act as a slave, or sometimes it can actually help you to store the configuration file. And then once the system starts, it will actually support for system configuration. So there are a lot of functionalities that you can have. So each of the concepts are actually different topic. Okay, so we will be discussing slowly one by one. It's a very vast topic. So very sim I will try to make your circuit design very simple as I showed you just now. Then we have they have like some GUIs or like software programs, so that we are not going to discuss right now. This is the power input. So the same concept I just told you just now, I had showed it to you. Like we have the input connector, we have a P MOSFET so that it can be switching. Basically this one I have already explained you in high side switching in LTS Spice as well, so you can see that tutorial and how they are like connected. So you once you make it high, it will pull it down. So this is the way power will be transferred. So the power is transferred from left side to right side. This is the way. This is what I was telling you. If you want, you can insert this particular filter so that it will be giving you a proper understanding of not sending the noises to the input. And this is the main, like power supply. I think no, this is not the power supply. This is just a enable pin. Okay, so this is enable. Then we have power supply system block diagram, like what are the different power supplies that is used, like 1 volt, 1.8 volt, 2.5 volt, 3.3 volt, 1.35 volt. Okay, so lot of like different voltage labels are used. We have 5 volt as well. Then we have several other like voltage regulators that is used for different purposes. So like let us say we have Ethernet, so they will be using different power supply. They have MIPI cameras and displays, so they will be using some other regulator. Similar to that, we have FTDDI chip, that is UR to USB bridge. So in that case, they will be using some other regulator. But we are developing a very simple system design, so that's the reason we have used only one regulator. Okay. So you can see device name and their proper functionality and everything is there, and what is the ampere rating and what is the voltage rating, that is there. So this way actually it helps you to choose your part number as well. Okay. Most of the parts you can see are there from like it is there from MPM. Basically it is nothing but MPS. Okay, monolithic power system. So you can choose either monolithic power system or maybe Texas Instruments or maybe analog devices, ADI. Okay. So there are several, like manufacturers for your power supply ICs. So basically I try going ahead with ADI always because they are very, like powerful in FPGA power supply designs. Then we have power supply, like sequencing. So during the like system design and concepts, I will tell you how the power supply sequencing actually occurs. Okay. So very first thing it will be 1 volt, then 1.8 volt, then 2.5 or 3.3. So basically 1 volt, then 1.8 volt, and then 3.3 volt. So this is the way it will be working. Okay. Then we have ADCs. ADC, this is the way it is connected. So ADC block diagram they have given very properly. You have JTAG connection, we have FPGA connection. This is the input that it is taking as a like a main analog input to your XADC pin. So either it can be like a differential signal, or even if you want you can have single indent signal also. So we have inbuilt 12-bit ADC. Coming back to the ADC system monitor and everything, so this is how same thing is there. All right, so hope you have now understood everything. You can see we have FMC connector, so that is nothing but your mezzanine card. So mezzanine card, if you want, you can see like what are the different pin numbers and what is their functionality and everything. So this actually helps you to directly connect several cards that is coming these days, which are compatible to your mezzanine connector. So you don't have to like develop your own circuit again and again. So they are like they are coming as plug-in boards, so you can connect them. So this was all about this particular like a user guide, and you are actually not supposed to use directly this evaluation board circuit design. It is just for a learning purpose and all those things. And you must understand that if you are using this in any system design or any like industrial design, you must consult your experts, or you must be liable by yourself. Nobody is responsible for that purpose. Okay. So, all right, hope you have enjoyed this particular session. And if you do have any questions or anything that you want to have, okay, you can please put down your questions in the comment box, because we will be proceeding to directly FPGA design techniques. Okay, so one by one concepts we will explore in the coming sessions. Thank you, guys.